Okay, that's not very helpful. Done. A level paper one recap. Okay, if there are any issues, I'm now streaming it onto my YouTube channel. I've made it public, so you should be able to see it. In terms of visibility. So yeah, coming back to what we were talking about, with Risc and cisc, each instruction may take multiple processor cycles. Remember, there's fetch to code execute cycles. So there's one fetch to code execute cycle, but takes multiple processor cycles. We didn't mention that, but single register set. Instructions may have variable formats. Many instructions are available, so large instruction set, as we discussed earlier. Many addressing modes are available, as we discussed earlier. And as Zahim was mentioning, this can lead to a more complicated processor design, which will make it more expensive versus Risc. Each instruction performs a simple task. Limited number of instructions, so a smaller instruction set. Complex tasks can only be performed by combining multiple instructions. So the example of multiply that we were talking about earlier, in a cisc, you might have one instruction called multiply. In a Risc, that will happen combining multiple adds in a loop together, or potentially logical shifting, and means a simpler design. And for the answer of what's the advantage? Well, in a Risc processor, the program is running faster due to simpler instructions. And we said specifically, it means that it's actually more straightforward to use pipelining techniques on a Risc processor. Right, okay, here we go. Here's next. Gosh, that's a bit small. So like I say, if you're struggling to see it, you can just go and click on the YouTube link. Obviously, the only thing is that you might want to stick that on mute because you'll hear me in both places. Operating systems can have different scheduling algorithms. So first of all, it's what are three of the scheduling algorithms? So can we remember three? And then why do we use them? What's the purpose of a scheduling algorithm? Okay, so those are the two things we need to get working at. Need to start thinking about. Why don't we just go for 3 minutes again, have a little think, and try and answer that question. Okay, guys, we can review in a few secs. Hopefully the first question's more straightforward, which is, stating a few, but sometimes those questions where you have to say the purpose of scheduling can be the ones that trip you up sometimes. So what's the goal of scheduling? Okay, so where were we? Oh, and in fact, we can review. It's worth looking here. So scheduling is coming under, where are we? Here we go. The system software section. We've got scheduling, round robin, first come, first served. So those are the ones they want you to remember. So in terms of scheduling, we've got these ones here. How does round robin work? Well, I'll tell you what, since I'm here, why don't I just go through these? So if you remember, round robin is where you all get an individual time slice. Oh, here we go. Yeah, each given a time slice. You can visually imagine it, I suppose, a little bit like a little pie chart. That a bit of time, and you will get a slot, a set period of time, and then hopefully it happens in this, and if not, it moves to the next one, and you have to wait until we get here. The issue with round robin is that you have to wait until it comes around here. So you have too many time slices, or if the time slices are too long, it won't feel very responsive. First come, first served. What data structure is first come, first served like? Yeah, absolutely. It's like a queue, isn't it? And I mean, these are all kind of variations of queue in a sense, but first come, first served, or first in, first out, as we learn a bit in here. But in here we call first come, first served. It's just a queue, irrelevant to what the job is. The job comes along and it happens here. Drawback of that, remember, is that maybe you've got some kind of job which is a high priority, and it will have to wait until one comes up. For instance, I'm doing something like, I don't know, this job here at the front is opening a web browser. This is me playing some music, and then I'm moving my mouse. Well, it'll wait for this to happen, and then my mouse will move. And of course, some tasks are higher priority than others, in which case we want to have things like a multi-level feedback queues. If you remember, that's trying to combine different bits of logic. And then we've got things like shortest job first and shortest remaining time. But you remember, they can cause issues where you can be continually waiting for a job to actually, a longer job never gets to the shortest job place. And so it ends up being starved of processor time and never getting processed itself, which would be a real problem. I would make sure I've learned all of these individual ones. If you look at it, this section here, right? We're anticipating things like 9 markers, right? Or even 12 markers. 9 marker on these types of scheduling algorithms, that seems entirely possible. Of course, a 9 marker interpreters, compilers, and assemblers, also possible. 9 marker and stages of compilation. A lot of these can be here. I just ensure that you've actually learnt it. So that was one part of the question. The other part of the question was, what's the purpose of scheduling? So in the time slice one, round robin one, this is often used in multi-user operating systems. So multiple users are using the same operating system. And so it's really important that all users get a fair access. So there's the users or the applications get a fair access to the processor, but also at the same time, you need to make it the most efficient. Remember, the problem I said here with the time slices, if the time slices were too long, you'd actually not be very responsive. So it needs to provide a reasonable response time. So if you're waiting it and it's getting really laggy, that's not great. But also, this issue of certain problems not being able to fail to run, processes being stuck on the shortest job first, not failing to run, or you have starvation of the processes not being utilized very much, is also kind of a problem that we want to avoid. So I've got here, over this side are the 4 ones here, but these are the things we've just discussed. So we've got to make the most efficient use of the processor resources. That's your number one goal. At the same time, to be fair to all users, or applications, depends what perspective it's being used from, to ensure that a reasonable response time is given. And then these are a bunch of the failing to run was the issue of, never getting the shortest. Starvation was this issue where the process has not been utilized very much. Maybe you're swapping very quickly from place to place and it's not actually being used very much. And deadlock, in fact, where have we met the concept of deadlocking before? Where have we met deadlocking as a concept?
Is that like record locking?
Yeah, exactly. Record locking. Yeah, databases. So we're in the situation where you've got a record, one person, what you need, if you remember, is you need to ensure to persevere, to preserve the value for atomicity so that a transaction needs to be fully committed. Two users are looking at the same, are looking at records. They lock them so that nobody else can change them, so that it preserves atomicity. But they're waiting for the other one to unlock the other one, and then you're waiting for each other. And you could have two processes waiting for the other process, which would also cause a deadlock. And these are things we want to avoid. Right, we got now talk of the devil. We're on to databases. Like I say, this is just going to be a 1 or 2 questions out of each one, just to give you a bit of a freshen up thinking about the things that we need to be thinking about. So this is under, where are we? I didn't do anything on little man computing since I feel like we've done a lot on that and on translators. So I had a look on here. We're going to have an SQL question, not quite yet, but we will do one. And then we're going to have a look at some of these other concepts. But I thought this is a database question that goes through a few sections. So I figured we could do this one together. Over here we've got, maybe I'll make it a bit easier for us to see. I've got this table. Oh, sugar, that's not going to work. There we go. I've got this table of data. The table is called users. An extract of users is shown below. What are each of these? Each of these is a bit of terminology. Each of these you could refer to as either a field or potentially an attribute if it was an entity relationship diagram. And across each of these rows is a record. Great. Describes what is meant by the term a primary key, giving an example from above. So a primary key, what's the quick definition? The definition is a
unique identifier.
Thank you. A unique identifier. Thank you, Will. Yeah, a unique identifier. And the example of the unique identifier here. Well, here's a question. Could I use username as a primary key? No, certainly not, because I could have a duplicate. I want to use the user ID as the primary identifier. So that's going to be my one there. And then moving along, we've got, what is meant by a hash? So this is all the encryption. I don't know whether this is going to come up or not because it's not highlighted. But I thought I'd just have a whole question on databases we go through. This is in the the encryption element. Remember you had asymmetric encryption, symmetric encryption, and hashing. So hash, remember, is where you apply an algorithm. Is used in things like hash tables. You apply an algorithm. The algorithm, which takes plain text or takes some kind of value and then turns it via an algorithm into a value. In a hash table, you use that to find a physical place in memory, and then you try to avoid duplicates by having it the reasonable size and using the mod function to spread them out evenly. Why would we store it? Why would we decide to use a hash? What's the property of a hash that's going to make it better for storing a password? Remember, so versus encryption, what is the advantage of a hash over encryption for storing something like a password? Yeah, it's irreversible. It's a one-way process. Yeah, it's a one-way process. So when you turn it into a hash, so the deal is when you provide your password doesn't go to the server to check if it's correct. A hash is made of your password, and then on the server, your password's not saved, but the hash of your password's saved, just like we saw here. So if we were to back out for a moment, when you submit your password, it's hashed and then it's compared versus this hash. And then if they match, that means that password is correct. And the advantage being is that the server is never saving, or the company or whatever you're using are never saving your actual password. Another situation where you might want to use hashing, guys? Another scenario? Sure, but I'm saying in terms of a database, something else we might want to hold about somebody. Yeah, private information. I was thinking credit card details, something like that. You really might want to keep on the hash table. You don't want to be storing that locally. But yeah, there's other private information you might want to keep secure. Having a look at the actual answers then. Yes, a unique identifier, user ID, a result generated. This is the definition of a hash. Resulted by applying an algorithm to a value. Hash functions are one way, can't be reversed, is what we said. And so if someone gains access to the database, they don't access the actual password, they access the hash of the password. Continuing this question. So this is the bit that will, well, I can't say will. Yes, no, I can say it will because it's on the guidance. So this will come up. SQL. SQL, remember, standing for, or short for structured query language. We've got this SQL statement to query, and then we've got one to update. Now, if you remember, when we looked through the actual guidance on SQL information, the function to do this wasn't actually included. However, this is in H406, H446, and it does in here in the guidance. In fact, let me go back to it for a moment. Do you see here? It's not just, it's interpret and modify. So the functions to modify, is it down here, 5D? No, okay, well, it's not actually on here. But the functions to modify, I think it's definitely worth us learning. So I got a question on both, to interpret the actual query and to modify the original data. Where are we? So we want a SQL statement to get the password hash and locked values of the user Apollo. So to do that, what we're going to need to be able to do, well, to be able to do that, we need to have to remember what the format for an SQL search is, for an SQL query. Something. Yeah, select. So the top line will be select. I'm not going to say which, and then the next underneath will do. So select. The next line is from, exactly right, and then finally, what's the last one we need to use? Where, exactly.
Table name.
Those are the three bits we need to remember. So I'm just going to give you oh, that's not helpful. I'll give you 1 minute to see if you can remember what the format's going to be for this question. Oh, that's small. Jesus. Well, let me see if I can fix that a bit. Okay, that's better, isn't it? So I'm giving you 30 minutes and 1 second. Nope. Okay, 1 minute. Have a little think. How are you going to answer that question? Jesus Christ. Did that make you guys jump? It made me jump. Alright then, go on then. Select what? What are we selecting? Go on, don't be nervous, guys. It's just us here. What do we think? What are we selecting?
Password hash and lock.
There you go. We're selecting the specific fields we're looking for. In this case, that's password hash and locked, as you say. What do I do between each of the fields? What do I do in between? Whoops, where am I? Comma. There you go. Thank you, Will. Thank you, Zahin. Password hash and locked. From where?
Users.
Yeah, from the name of the table, which in this case is users. And then finally, where what?
Username equals Apollo.
There we go. I got a question for you guys. Let's see if this... Do you think I've made an error? Tell me if you can spot any errors. I'll tell you when. Tell me if you can spot any errors.
Apollo needs to have speech marks in.
Apollo needs to have speech marks in. Yep. Totally right. Any other errors? Okay, cool. So why do I only have a single equals? Because it is a comparison. So I've got a single equals here. How come? How come I'm not using a double equals?
Because it's not Java.
Yeah, well, it's SQL is not designed, is tried to be easy for people to use, is the idea. It's not meant to be for sort of developers or whatever. So it's a single equals here, which is I know is normally for assignment. All right, okay, so that went reasonably okay. Why don't we have a look on this other side? So for this one, we've got sometimes users have their accounts locked if they behave inappropriately. When this is the case, the lock field is set to 1 rather than 0. Write a SQL statement that locks the account of the user. Now, can we use select to do this? Can we use a select statement to...
No, we use update.
Okay, great. So the first line is update. Anything else we need to do? In fact, what am I doing? Let me be consistent. I'll do update in capitals. I think that's worth doing. Okay, update. Anything else? So anything else? So update. What's the next line going to be? Ooh. Where are we at, Will? Oh yeah, update. Yeah, you're right. I'm saying, like, you know, before it was select, from, and where. For update, it's update and then what? Set. That's right. So update and then set and then finally where, right? Because otherwise we won't specify where it's happening. Okay, give you another minute, guys. Try and write this one. Mother of God. That scares me every time. All right. So update. And actually somebody, I think you said, Will, didn't you? So we're updating. For this time, update is going to be users. So we're updating the name of the table. We need to say which table we're updating. Set. What's for set?
Locked.
Yeah, there you go. The actual field locked. Anything else we need to say about it?
Equals 1.
Yeah, there you go. Equals 1. Question. Whoops. Any mistakes?
No need of speech marks.
Why is there no need for speech marks?
It's not a strip.
What do you reckon it is?
It's an integer.
Yeah, it's an integer, so no need for the speech marks. Brilliant. And then finally, where what? Where. So this is the criteria, isn't it? So where what?
Username is equal to Hades.
Bingo. Username. And anything else? So how should I write this out? So I'm going to write username. Exactly how they've done there, all lowercase. What's the next thing I need to do? Equals, you said. Anything else I need to bear in mind with Hades?
Speech mark.
There you go, speech marks. Okay, brilliant. Oh, here we go. Here's a challenging one. You know, paper 2 has more programming on it in general than paper 1, but is there programming on paper 1?
Yeah.
Most definitely. So here's a fun challenge for us, okay? We've got here, I'll give you the thing here. The function check access takes in the password the user has entered, the given password, along with the password hash and the locked value locked. So this function is taking in 3 parameter values, and you can see over here, this is the function check access, the name's check access. I'm not gonna, I've said this so many times. So a function, remember, it's going to return a value as opposed to a procedure. It's taking in 3 parameter values, given password, password hash, and locked. Okay, using those, password hash and locked have already been extracted from the database before being passed to the function. So we've got the raw value. It should return the value true if a user should be allowed to access a system, and false if they aren't. Your function should make of the pre-written function hash, which takes in a string and returns the hash of that string. So it's this one here. So this is building on the stuff we've just done previously. So we're going to have to use the hash function. We've been given the password. We need to check to see if it's locked or not. So your job is to be able to sort of combine this logic together. I've given quite a few lines here, but realistically, you know what? I think you can do this in about 4 or 5 lines. I think 4 or 5 lines. And just remember, you're going to have to return true or false depending on the outcome. I'm going to... Do you guys feel how confident you feel if I give you 3 minutes to write it? And you guys feel super confident? Yeah, okay, wicked. I'm going to mute this because that keeps scaring the life out of me. All right, give it a go. Okie dokie. Let's have a look at this, shall we? Where are we? There we go. So, no, I'm not. That's right. For a second, I thought I might be on mute. So, yes, let's think it through. How are we going to write this function? Well, it's taken in this given password. What did we say we're going to have to do with this given password? We're going to have to turn it into a hash, right? So, I'm thinking something like, well, you could temporarily hold it, but I think it'd be easier just to do an if statement. So if the hash I don't have to make it that big. There we go. If the hash of, what are we going to pass it? What do we pass to this? Yeah. Yeah, exactly. If the hash of the given password, so if this is, I don't know, JCA rules, that'd be weird. CLF rules. If hash a given password, right? So that's a function. We send it this as a value, and it's going to return the hash. If that's the same as what? What are we going to compare it against? There you go. Yeah, exactly. Anything wrong with my statement there? Yeah, it's the simple things. Now, I think if I was going to do this now, if I was writing the code, I'd say I put an and here, and if it's locked is equal to 0. Unfortunately, I kind of snookered myself because I don't really have enough space, so I'm going to have to like do some kind of nested if statement. So if we're here, oh, this is ugly. And if locked has to be, well, if it's 1, it's locked. So if it's 0, it's not locked, I guess. And that's locked. I suppose, yeah, we should say return. Okay, I've really snooked myself here. This is so ugly. My apologies. So returning, what we're going to return at this place. What would we return? If the, yeah, return true. There you go. Beautiful. Return true. How I've made this really ugly is I'm going to have to do two separate else's, aren't I? Because if I just did an else here and said return false, would that work? I mean, are there any problems? Any problems with the sorry? Hello, Solomon. There's a YouTube stream of this, Solomon, so if you want to, you can go back and catch up. We'll probably go for, I don't know, another 10, 15 minutes, something like that. Yeah, I think it would be better. Remember, ampersand is a shortcut in Java. In this, you'd literally write the word and, just in case the ampersand throws people. So, guys, what's my solution? Is this going to work perfectly, or is there anything wrong with it? Come on, debug my code. Is it fine, or is there any problems? Yeah, I need another return false, exactly. So if the password matches, but it's locked, then it's returning false. If the password matches and locked is 0, then return true. But if our password is wrong, right, currently it's not doing anything. So I need to have a separate else for this and return true, return false, sorry. There we go. But like I say, that's kind of ugly. You'd be better off, doing an and. So if hash given password hash, and locked is equal to 0, return true, else return false. Okay, look, more fun database questions. Fantastic. So what we got here, on one side we've got, in fact, why don't I do this at the same time? So we've just done some SQL stuff. We need to have a look at this. Transaction processing in terms of ACID, atomicity, consistency, isolation, durability, and record locking and redundancy. There's not that many questions on this one, to be frank. But we got this one here. We've got this entity relationship diagram, one to many, many to one. The database management system ensures referential integrity is maintained. If you remember, referential integrity is when, for instance, let's say a user has made a review, and then later on that user is deleted. Their reviews should also be deleted. That would be enforcing referential integrity. Also, if a restaurant is here and is deleted, any reviews of that restaurant should also be deleted. So here, whenever a review is added to the system, the restaurant's average rating is updated. This transaction is ACID. The A in ACID refers to atomic. State what the letter CID stand for in ACID. So, oh, we've just looked at it. Gosh, my bad. Yeah, so we've got, if you remember, yeah, consistency, isolation. No, it's isolation. So we've got consistency. Where are we? Here we go. Consistency. Isolation. And durability. Ooh, that is not easy to see. There you go. So by consistency, we're saying that we're enforcing all the validation rules should be met, etc. Isolation, we're saying that if you've got two transactions in parallel, the outcome should be the same as if they were one after each other, which is why we get things like record locking and time serialization to fix it. And then durability is about making sure that any fault, hardware fault, or if there's a fire or if something's happened, that you're able to sustain it, so it's not going to just lose your data. Now, it's not asking you about that. It's asking you about the first one, which is, they call it atomic, but actually on the specification is atomicity. Data being atomic, if you remember, was one of the first things that happened inside. I don't like this question, because atomic is one of the first things that happened when we looked at normalization, and atomic data is when it's broken up as simple as possible. For instance, you might have someone's address, like, I don't know, 10 Downing Street. You should break it down to 10, and then Downing Street's a separate part, their postcode's a separate part, you break it into pieces. Like your name, it shouldn't be title, first name, surname. Each of those should be separate fields. The A in ACID, they refer to as atomicity, which is kind of similar, I guess. Whenever a review is added to the system, the restaurant's average rating is updated. The A refers to atomic. Describe what is meant by the term atomic in the context of ACID transactions. You should refer to the example. So what do we reckon? It's not actually, it means atomicity. It doesn't mean atomic in terms of being broken up. It means the atomicity in ACID. Why don't I give you a minute or two to have a little think, and then we'll review the answer. Ooh, that's not helpful. Right. How did we do? Atomicity. Anybody remember what it refers to? In fact, let's remember that we're always talking in terms of this phrase here, a transaction. A transaction, if you remember, that could be updating a database value. That could be the SQL query to update, could be to search, could be to delete a file, could be, or a record, could be to update a field. Each of those is a transaction. So in terms of a transaction, what do we mean by atomicity?
Like a transaction must be processed in its entirety or not all.
That is exactly right, Ian. Exactly right. Yeah. So it's either going to fully happen, a transaction will fully happen, or not at all. So no incomplete or partial transactions. That's exactly right. In fact, let's have a look here. So a transaction can only fully complete or not complete, cannot partially complete. So there's one mark for that, and then the second mark, you have to apply it to this context. So in this case, it should not be possible for the review to be added without the average rating being updated, because they've given you that context, haven't they? They said what happens. So you have to link it back to this. For instance, if it was around consistency, let me just discuss this for a moment. Consistency, remember, was following all the validation rules and the data integrity elements. So for instance, let's say in here it said that an average rating had to be less than 5 and greater than 1. Then in this case, it wouldn't happen if the review generated over 5, so let's say it was 6 out of 5, it should be rejected because it's not being consistent. In isolation, the example could be 2 people editing or editing the records, and so it should be that the outcome should be the same as if they happen one after each other. And I guess durability will be about making sure that the data is being, that the transaction when made is held permanently. So like I say, in the example of a fire or a hardware failure, there should be backups in place or rollback systems in place that the data is not lost once it's been written to or read from. Right, here we go. This is fun. So, in fact, why don't I go back and look at the overview? Where were we? One too many windows open. There we are. Networks. So most of networks is not here, but it says there's one on the internet structure and then on the TCP IP stack. They're the two elements they've really referred back to. So I dug this question out from one of the recent papers. I can't remember which one. And it's saying you need an example of what a WAN is. Guys, what does a WAN stand for? Yeah, a wide area network. You can consider the internet the ultimate WAN, right? Because what a WAN really does is it typically links LANs over large distances, over a remote connection. So, you know, in John Cabot Academy, we have a LAN, we have all the computers in all the different rooms all linked together. You know, even in the eye, that's still in the same LAN with a little bridge in between. But it's actually connected. All the academies are kind of connected to each other over a wide area network. Remember, in a LAN is over a small geographical area, such as a single building. A WAN over a wider area. But the really things that's important to get in there is, because it's easy to say, oh, a WAN is over a wide area, and that's not going to get you any marks. What you want to say is that in a LAN, who owns all the cabling and stuff, and switches and hubs? The company or the organization own it. So John Cabot Academy in our school would own it. But what about connecting up all the individual schools? Or if you're Argos, connecting all the Argos shops to each other? Well, they're not going to be digging up the roads and putting their own connection in. They're going to use third-party cabling to be able to do it. So that's one of the big ones to go to. And then it's saying why protocols are important. Okay, what is a protocol? Why is it important? And then the 4 layers of the TCP IP stack. I think to do that, you're going to want to remember the acronym that we've tried to learn. Right, there's quite a few questions there, but don't think any of them are going to take that long. So if I give you, say, 3 minutes, I reckon that's enough time for you to give all of those an attempt. Yeah, that is the acronym. What does it stand for? Is the next bit. So you got 3 minutes. Like I say, I think we'll do about another 5-10 minutes. I don't want to be this onerous on you. Remember, this is just a catalyst to get you started, get you thinking about questions, and make sure that you get yourself off on the right foot for this half term. Anyway, 3 minutes to try and attempt this question. I've got 22 seconds. Also, the mic's on. Okie dokie, let's review. So this is all really about core definitions. So yes, you can get a mark for saying, in this case, you can get a mark for saying wide area network. Be very careful about that. These days, they're very hesitant to give that mark. But a collection of computers over a large geographical area, that's the kind of one that you want to go for. And using third-party communication channels. Why are protocols important? Well, at GCSE you learn that it's a set of rules that govern communication. But what's important in this case is that we both follow the same rules, the same standards. If one person thinks that you should, for instance, so in a TCP/IP stack at the transport layers, when you decide the size of each individual packet, well, if one person decides it's 1,000 bytes, the other person decides it's 750 bytes, one will chop them up a certain size, and then the other side they'll put them together at the wrong size. So we have to. It's not just that we have to follow these set of rules is that both parties have to agree on all these standards. So all communication over TCP/IP has a set of standards that we all agree on, so that they interpret the data in the same way. Absolutely. Yes, and then we've got ATIL. Remember, the application layer is where we apply encryption like HTTP, SMTP, FTP. Transport, that's when you have a connection, you establish a connection between two different devices. And then you also start splitting it into individual packets and number them. Internet is when you apply the IP elements, you put the IP addresses onto individual packets. I think in transport as well, we're talking about the error checking element of it, like a checksum or something. And then at the physical layer is when we're doing things like applying MAC addresses, so that we can actually send them physically to the different parts. And this is also including things like the physical media elements like Ethernet and stuff at this layer. I've managed to balls this one up a little bit. So there's this question around another one on the TCP IP stack. What is meant by the TCP IP stack? Well, you get a mark for saying it's the transmission control protocol / internet protocol. You get a mark for saying a protocol is a set of rules for governing communication, for communicating across the network. That each protocol belongs to a different layer and what the name of the layers are. And the data is encapsulated as it's passed to the next layer. It's a bit like why do we use layers? Well, it's a bit like why do we use subroutines? There's many reasons why we use subroutines. So it makes it people in a team can work on different elements of it, so that you can. But one of the bits is that you can work on one element of a subroutine, and then you can test it individually. And if there's a bug, you can isolate it to an individual or logic error. You can do black box testing, and then you can identify the error in that particular subroutine rather than have to go everywhere. It's the same here with layers. Then if there's a problem, you can find that the actual problem at the individual layer level, and then you can debug at that stage. I've done another one here. ASCII, character set, that comes up sometimes. So you can say things like, it's all a combination of symbols, letters, and numbers. The bit that people miss out sometimes is that represented by a computer. Literally the definition of a character set is that can be represented by a computer bit is often missed out. This is ASCII, so it's saying 7 bits for standard ASCII, 8-bit for extended ASCII. Mark for saying it stands for American Standard Code for Information Interchange. The other type of one, of course, would be Unicode. And I guess when you talk about Unicode, about the fact that it's got much more functionality, you can have a lot more different values. And then I was going to kick off for the last one on another function one here, but looking at it, I think I've asked you to do this a couple of times here in the past. Okay, here's what I would suggest. The big packs of questions that I've given you, on the individual topics, definitely make use of that. But also bear in mind, I've given you the whole paper to do, like, the most recent paper. I mean, that's most definitely worth going your way through in paper 1. We're only talking about paper 1 right now, but I mean, if you're sensible, you can do a little bit of work on paper 2, because otherwise you don't want to hit it cold. Remember also things like object orientation. Is it stated here in paper 1 that it's going to be included? No. However, the fact is on paper 2, maybe it will mean that it will come up on paper 1. Certainly, historically, maybe you were asked more to write the code in paper 2, but you might be asked to define what is inheritance, what is encapsulation, what is polymorphism. Questions like that can come up, so I'd really have a go at it. I'm going to need to go and feed my kids their lunch before they riot, because I've kind of locked them out so far. Are there any particular questions you'd like me to answer right now? Because if not, I'm going to have to do my duties as a mid-rate father. Okay. Any particular questions on a particular subtopic, guys?
No, I'm all good.
Okay. Right. Well, it's been an absolute pleasure. Hopefully, this has given you a bit of a spur over the a half term to get started. I mean, the earlier you start, the better off you'll be. Real pleasure to spend an hour and 20 minutes with you guys. And yeah, I look forward to seeing you in the new term.
Thanks, sir.
Thanks, guys. You take care of yourselves.